Hello, my name is Andrew Nebungo. I'm an educator and a scholar at Grand Canyon University. So today I'm going to be doing a presentation to present a video on Chem 515, which is concepts of inorganic chemistry. So what am I going to be presenting in this video? So I'm going to be presenting a summary about an element. So I chose carbon as an element to present its existence, reactivity, and application of carbon and its compounds. So I'm going to be doing a summary here. Now, for this summary, we are going to start by explaining the fact that carbon is a fundamental element to life on Earth itself. So, and with that, we know that carbon has a lot of applications in many different industries. Like in chemistry, carbon has applications in organic chemistry, carbon has applications in material chemistry, carbon has applications in environmental chemistry, carbon has applications in different industries, different branches of chemistry, different branches of science as well. Now, carbon in its natural form exists in three different forms, or we can call it the allotropes of carbon, which are diamond, graphite, and you have amorphous carbon. Now, looking at how carbon can be extracted, I will just give a brief summary of how you can extract carbon. Now, carbon can be extracted by either mining carbon, mining coal, or can be extracted by refining it, refining petroleum, refining petroleum and natural gas, which can lead in the production of hydrocarbons, or you can do carbon capture from the atmosphere. That's a summary of how carbon can be extracted. Now we are going to look at the physical and the chemical properties of carbon. Now, for the physical properties of carbon, as we said, carbon exists in three different forms, which is diamond, graphite, and amorphous carbon. Now, these different forms which carbon exists are related to its atomic structure. Now, for diamond, we all know that diamond is extremely hard. Diamond is a poor conductor of electricity, and the diamond is transparent. While graphite, on the other hand, graphite is slippery, it is opaque, and it is a very good conductor of heat and electricity. We know that amorphous carbon lacks a defined structure, which gives it variable physical properties. For the chemical properties of carbon, these chemical properties stem from the electronic configuration of carbon. Now, from the electronic configuration of carbon, can form four covalent bonds, which enables carbon to create complex molecules. Then carbon can undergo a phenomenon known as catenation, which is the ability of carbon to form bonds, which is the ability of carbon atoms to form bonds within themselves, which leads to the formation of long chains and rings of organic compounds. Carbon has the ability to form multiple bonds, which it can form single bonds, it can form double bonds, it can also form triple bonds. Okay, this enhances the versatility of carbon bond formation with other elements. Now we'll look at the major uses of carbon. Now, carbon, as I've mentioned from the beginning of the video, that it's very essential to life itself on Earth. Therefore, it has numerous applications, but here we are going to be looking at a few of them, which is a summary of what we have. Then we are going to look at energy production. We know that fossil fuels, which include oil, which include coal and natural gas, are primary energy sources for the generation of electricity and in transportation system. We also know that carbon fibers, which are used in material science, carbon fibers and composites are used in aerospace and automotive industries for their strength and their lightweight properties. We also know that the carbon compounds are also essential in the production of plastics. They're essential in the production of plastics. They also used in the production of pharmaceuticals and also used in the production of fertilizers, which are used in agriculture. We know that that's why carbon is very important. And then we also know that graphene, which is a form of carbon, graphene and carbon nanotubes are also utilized in electronic devices because of their superior electrical conductivity and mechanical strength. Then we are going to look now at a summary of the fate of carbon in the environment, in the environment, which is known as the carbon cycle. Now you look at photosynthesis. Well, here we know that photosynthesis, plants absorb carbon dioxide from the atmosphere and they convert it into organic matter, which forms the basis of the food chain. And we also know that during respiration or decomposition, organisms release carbon dioxide into the atmosphere through respiration and decomposition of organic matter. Then oceans also absorb carbon. They absorb a significant amount of carbon. And then we have also, after millions of years, you also have the formation of fossil fuels. That this is a fate of carbon in the environment. Then we will also look at the next stuff that we are going to look at. I said I will be giving a summary on the existence of carbon, the reactivity of carbon, and the application of carbon and its compounds. But however, we cannot talk about just that without mentioning the toxicological effects of carbon and its compound to our environment and our atmosphere. So I'm going to be looking at the health risk of the emission of carbon. The first one is during incomplete combustion, carbon dioxide can be emitted. If inhaled, it can cause serious respiratory issues and even death sometimes. For polycyclic aromatic hydrocarbons also, which are also formed during incomplete combustion of carbon-rich materials, can also contaminate air and water. We also have soot and carbon black formation, which is also a byproduct of carbon combustion, and also can lead to respiratory diseases and cardiovascular problems in humans. Then we are also going to look at how to quantify carbon in our environment. How do we, different methods that we can use in quantifying carbon in our environment. We can use elemental analysis, which is a technique such as combustion analysis, where it is measured. You measure the total content of carbon by burning a sample of carbon and analyzing the release carbon dioxide, the amount of carbon dioxide which is released. From there, you can now calculate the content of carbon in that material. We can also use NMR spectroscopy to identify and quantify specific carbon compounds. We can also use gas chromatography. You can also use liquid chromatography, which these ones enable the separation and the quantification of volatile and non-volatile carbon compounds. Okay, so from all that I have tried to summarize, we know that carbon is very sophisticated. Carbon has carbon forms millions of different compounds. Therefore, these compounds have enormous applications in different areas of science. So this was just a summary to present this for this particular course. Thank you for watching the video. See you in my next course.